Hi, this video is about the wilcoxon signed rank test. The wilcoxon signed rank test is a non-parametric alternative of paired samples t-test. The wilcoxon signed rank test is used to compare the difference of two related samples by adding the signed ranks of paired data. The signed rank here indicates that you apply the sign function for the difference. When the difference of a pair is not zero, the sign function will result either +1 or -1. Let's consider the following example. Company A and B and C launched new products and consumers are assessing the design quality by ranking the three. In total, 25 consumers have ranked the three products in order of their design preference. For instance, this person ranked the product of Company A as the best, and then product from Company B, and then C. When we simply average the mean ranks for each company, they are 1.84, 1.56, 2.60 respectively. The more preferred, the smaller is the number. Accordingly, based on these means, perhaps we can conclude that Company B is more preferred than Company A or Company C. But in order to examine this, we can conduct the wilcoxon signed rank test. It is a kind of a mean comparison of paired samples, but the measurements are in a hierarchical scale. Therefore, as a non-parametric alternative for the paired sample t-test, we can choose the wilcoxon signed rank test. Here we have three mean ranks, but let's focus on the comparison of two mean ranks from Company A and Company B. So we are interested in examining whether the two mean ranks are statistically different. We can formulate the question in this way. Is B ranked higher than A? In fact, based on the observation, A beats 10 times, whereas B beats A 15 times, and the mean rank of Company B is higher than the mean rank of Company A. Again, the data are measured in a hierarchical order, and therefore, we need to perform a non-parametric alternative for the pairwise samples t-test. The wilcoxon signed rank test is the technique. You don't need to memorize all this procedure. My intention here is to make you to be more familiar with playing with numbers or viewing numbers, and that's all. So let's see here. We need the W score for the wilcoxon signed rank test. As explained earlier, apply the sign function for the pairwise difference. The sign function converts a pair of numbers into +1, 0, or -1. In case of a consumer number 01, the subtraction A from B is actually 2 minus 1, and it equals to 1. Consequently, sine function for this comparison results +1. And then we rank for the differences. The size of the differences are compared in their absolute value. The rank of a difference in absolute value is then multiplied by the sine function. Then we add all. That's it. For the wilcoxon signed rank test, we refer to the normal distribution. Therefore, the z value is needed to be calculated. In the wilcoxon signed rank test, the z value is obtained through this formula. The standard deviation is obtained through this. The NR indicates the reduced number of the pairs by excluding the number of equal pairs. In this table, no pair has the same number because evaluators gave always different ranks for each company. So the NR in this case is equal to the size of the sample, which is 25. In SPSS, the standard deviation for the wilcoxon signed rank test is obtained through a little bit more complex procedure than this. So I recommend you to mention in which software, for instance in SPSS, you have performed the wilcoxon signed rank test. Okay, then let's move to the Excel and then SPSS. Okay, then let me demonstrate to you how to calculate the W and the standard deviation in wilcoxon signed rank test. So first, we calculate the difference. Because we focus on the comparison of mean ranks of A and B, we hide the data for company C temporarily, and we calculate here B minus A. Okay. Then we need to rank this mean difference in their absolute value, so we need to calculate, or we need to convert the difference in absolute value. And then we rank the absolute differences in ascending order. F. Okay. So here, rank, average this number in here in ascending order. So because there are many 1, right? So the mean rank is 12, and the other one also 12. 12 for many times, right? So they are tied rank. In Korean, 공동 12위. Okay, then for this difference 2, rank, rank in here and in ascending order, 4.5, and this is All right. Then let's perform the sine function. So sine function is if this difference is smaller than 0, then -1. Otherwise, if this equals 0, then 0. Otherwise, +1. Okay. All right. So we add the multiplied value okay, and therefore the W is sum of here -85, and the standard deviation, the sigma W, is the NR was 25, so 25, and then 25 plus 1, 26, and then 2 NR plus 1, so 50 plus 1, 51, divided through 6, and this will be square rooted, so like that. Then Z is W minus 0.5 divided through standard deviation. Okay. If you remember the threshold value in normal distribution, when the alpha level is 0.05, it was -1.96. And this Z value is within the tolerance. So in terms of the absolute value, this Z score is smaller than the criteria value 1.96. Therefore, the difference of mean ranks between A and B, it's still acceptable area to be considered as not different. Therefore, although we found that company B got a bit more preferred, but the statistically the mean difference is not significant. And now in SPSS, so let me perform the wilcoxon signed rank test regarding the ranked data for company A and B. Analysis, non-parametric statistics, and paired two samples are already prepared. So initially it was like that, and I selected these two for the comparison, and I chose wilcoxon and click. Very quickly, everything is done. SPSS doesn't result the W value. It generates the Z value directly, and W value actually can be seen here. So you can consider this negative rank as the minus value and this plus. So if you add this, that will be -85. If you remember this -85, then actually this indicates the W value. So based on that W value, and as I explained earlier, SPSS has its own a little bit different calculation for obtaining standard deviation. So it results the Z value a little bit slightly different from here, but it also tells us that the difference of mean ranks are not statistically different. This Z value is also not reach the criteria either. So now we are back in the initial research question. The question was whether B is ranked higher than A, or the difference of mean ranks of these two are statistically different. And we have performed the Wilcoxon signed rank test because these are measured in hierarchical order. So we chose a non-parametric alternative of a pairwise samples t-test, and the Wilcoxon signed rank test yielded not statistically different, right? The difference was not statistically significant. Therefore, although we have observed that the product from company B is more preferred by these 25 consumers, we cannot yet conclude that the tendency is statistically significant.